In this video, ladies and gentlemen, you're going to take a look at a mixture problem. So in the sections of this video, you're going to look at the connections between weight, cost per pound, and value. And you're going to see a problem done with a graphic organizer. It's exciting times. Let's get started. This is MATHguide.com, and my name is Mark Karadimos. In order to understand the connection between weight, cost per pound, and value, we should take a look at a problem. If someone were to buy 3 pounds of $4 per pound cheese, how much would it cost? Give it a try. Yeah, did you try? Well, if you calculate this, you should realize that if you've got 3 pounds and you multiply by $4 per pound, well, you should see that if you're multiplying these, of course you're going to think of this as a fraction. When you multiply fractions, you always see what can you cancel. In other words, what factors on the numerator and denominator can you cancel? Well, you could see that here. In this case, the units will cancel. And so when you land up multiplying across, because that's how you're supposed to multiply fractions, you're going to get $12. Okay, so that means if you were to buy 3 pounds of this cheese, it's going to cost $12. That is the value of cheese that is being purchased. So clearly we could see in this problem that if you take weight times cost per pound, you get the value. Well, what if you did this problem in reverse? What if you had $12 worth of cheese that cost $4 per pound? What would you do to figure out how many pounds of cheese would you have? Well, you would take $12. You would divide this by $4 per pound. What? Dividing? Well, when you're dividing two fractions, you should already know that there's a relationship where you change to multiplication and do the reciprocal. Okay, now in this case you could see that if there is a unit that's going to cancel, it's actually the money unit. The money unit lands up canceling, and we multiply across. We get 12 pounds divided by 4. And we can clearly see that this is 3 pounds. And we get back to our 3 pound beginning. Okay, so we either take weight times cost per pound to get value, or in the case that we know, like let's say, if we know the value, we could divide it by cost per pound to get the weight, or we could take the value divided by the weight to get the cost per pounds. So working backward you divide, working forward you multiply. All right, let's see how this works out to do an actual mixture problem. Who does mixture problems? Well, there's a whole bunch of different type of people in different types of professions. Like for instance, chemists, they mix chemicals, and the chemicals have different costs. There are cooks, when they create recipes or follow recipes, the items of the recipe have different value, so and different costs. So anytime people mix things, like car manufacturers are mixing car parts, just to give you a broader look at what mixture problems look like, anyone who takes something to mixes them, and the things have different costs, then you have to figure out what is the cost of a mixture of things. Well, anyway, let's take a look at how these mixture problems look, and we're going to look at like a food mixture. Sometimes we call these a trail mix. So let's say that we were looking at this problem where a supermarket is going to mix 2 pounds of cashews, a half pound of M&Ms, and a pound of mini pretzels. And so they create their own mixture and mix all these items together, and they want to sell this. So you want to figure out if those are the prices of the individual pieces, what's it going to cost as a mixture? Okay, so that's kind of the problem that we're dealing with here. So in order to solve this problem, which looks kind of complicated, I would strongly suggest that you use this graphic organizer. So this table is set up in such a way to make it easy to use. Earlier we saw that when we took weight times the cost per pound, as long as the weight is in pounds, when you multiply these two together, you're going to get value. So I always like to set up my tables so that you can multiply across. So that's why I'm organizing the columns like so. Okay, so I've chosen my column headings very carefully. All right, and if you follow this, it shouldn't be too bad. So what I'm going to do is just start to put these items that are being mixed into the graphic organizer. So the first thing we have are cashews, then we have M&Ms, and then we have, let's see, mini pretzels. MP for mini pretzels. So we know that we're using 2 pounds of cashews. We're going to use a ½ pound of the M&Ms, and then we're going to have a pound, 1 pound of the mini pretzels. Now we are also given the costs. We know that the cashews are the most expensive here. It's costing $9 per pound, $6 per pound for the M&Ms, and then we've got $1.50 per pound for the mini pretzels. Now remember, I have this set up so that when you could multiply straight across. Weight times cost per pound. Remember the weight's in pounds, so the units all match up. I can multiply across. So we've got $18 worth of cashews being mixed together. A half times 6, or half of 6, is $3 worth of M&Ms. And then we've got 1 times $1.50. We've got $1.50 of mini pretzels. All right, now part of the problem is figuring out what the total looks like. All right, well, our total is going to be, well, let's see, what's the total weight? So 2 plus a half plus 1, that's 3.5. And I'm just going to use decimals here. Let's see, cost per pound. See, I can't add this up because this is a different mixture. See how it's a ratio? It's a ratio of weight, value to weight. Value to weight. So you can't add these. It just doesn't make any sense to add these. But I can add the value. So if I were to buy 2 pounds of the cashews, that'd be $18 at a register. Half a pound of the M&Ms, that'd be $3 at a register, and so on, right? I could add this up to figure out what's the total cost. So let's see, this is 18, 19, 20, 21, 22. This is $22.50. $22.50. All right, so let's see, I've got the total weight in pounds. I've got the value, this is the cost, total cost, right? So if I were to take that and divide it by the weight, I would have basically the cost per pound. And that's what I'm going to do. Now, actually, I did that earlier. And it turns out if you round this to the nearest penny, you get $6.43 if you round it. Okay, so that is the cost per pound. So let's answer the question. How much would this mixture cost per pound? So it's $6.43 is the cost per pound. All right, and then how much of it was made? It looks like we've got 3.5 pounds of mix. And there you go. We've solved the problem. Thanks for joining me. Make sure you come back and look at more MATHguide videos. So, we've got hundreds of interactive quizzes, hundreds of lessons, and hundreds of instructional videos. Take care.